Hello students, now let's solve the problems on Fourier series. Obtain the Fourier series for f of x equals to sin mx in the range minus pi to pi where m is neither 0 nor an integer. Okay, whenever you ask to find the Fourier series, you check the interval, next you check the nature of the function. Okay. First, here the given interval is minus pi to pi, means f of x is defined in the interval minus pi to pi. The Fourier series of f of x having period 2 pi is given by, means let us solve the problem by taking the Fourier series of period 2 pi. F of x equals to a naught by 2 plus summation n equals to 1 to infinity n cos nx plus summation n equals to 1 to infinity bn sin nx. Let us take it as the equation 1. Now we need to check the nature of the function. Okay. To check the nature of the function in the interval minus pi to pi, we need to substitute x equals to minus x. That is f of minus x equals to sin of minus mx. That is equals to minus sin mx. Sin of minus theta is minus sin theta. Like that, minus sin mx. Okay, this is nothing but minus f of x. Okay, since f of minus x equals to minus f of x, f of given function f of x is odd nature. Given function f of x have the odd nature. Okay, since the function is odd, the coefficients a0 and an becomes 0. We need to find the value of the coefficient bn. Now we are going to find the value of bn by taking the expression bn is equals to 2 by pi integration 0 to pi f of x into sin nx dx. That is equals to 2 by pi integration 0 to pi sin mx sin nx into dx. Means f of x is sin mx into sin nx dx. Okay, sin mx into sin nx. Now these are two trigonometric functions in the form of a product. We are going to apply the product rule. We know that sin a sin b is equals to 1 by 2 into bracket cos of a minus b minus cos of a plus b. Right? This is a transformation formula. By applying that formula, we can write bn is equals to 2 by pi into bracket 0 to pi 1 by 2 cos of m minus n into x minus cos of m plus n of x into dx. Next, we need to integrate the function. Here 2 cancels, 1 by pi into bracket 0 to pi cos of m minus n of x dx minus integration 0 to pi cos of m plus n of x. Integration of cos of a function is sin of a function upon that function. Sin of m minus n of x upon m minus n minus sin of integration of cos of m plus n of x is sin of m plus n of x upon m plus n between the limits 0 to pi. Next, substituting the limits, that is 1 by pi is equals to 1 upon this 1 upon m minus 1 keeping constant sin of m minus n pi minus sin of 0. Here lower limit 0. Next, here 1 upon m plus 1 n keeping constant sin of m plus n of pi minus sin of 0. And we know that sin 0 is 0. Multiplying pi to the bracket terms, here also 1 by pi into bracket 1 upon m minus n. That is, next multiplying pi to this bracket sin of m pi minus n pi minus 1 upon m plus n into sin of m pi plus n pi. Now it looks like sin of a minus b sin of a plus b. Again applying the compound angle formula for these two terms. We have 1 upon pi into bracket 1 upon m minus n sin m pi cos n pi minus cos m pi sin n pi minus 1 upon m plus n into bracket sin m pi into cos n pi plus cos m pi into sin n pi. Sin n pi is 0. Therefore, we are left with 1 upon pi into bracket sin m pi cos n pi. Right? This term becomes this term and this term becomes 0. We are left with sin m pi cos n pi sin m pi cos n pi. taking these two terms common, 1 by pi into bracket sin m pi cos n pi into 1 upon m minus n, this one, minus 1 upon m plus n. Next, for these terms, taking the LCM and simplifying, that is 1 by pi into bracket sin m pi cos n pi into bracket m plus n minus m plus n upon m square minus n square, nothing but m minus n into m plus n is m square minus n square. Next here, m cancels, plus n is 2n, that is 1 by pi into sin n pi cos n pi, sin m pi cos n pi into bracket 2n upon m square minus n square. And we know that cos n pi is nothing but minus 1 raised to n. Therefore, bn is equals to n into bracket minus 1 raised to n sin of m pi upon pi into bracket m square minus n square. This is the value of bn. Substituting the a0, an, bn values in equation 1, we get the required Fourier series. F of x is sin mx. Sin mx equals to summation 1 n equals to 1 to infinity 2n into minus 1 raised to n sin m pi upon pi into bracket m square minus n square into sin nx. This is the required Fourier series for the function sin mx. Let's go for the next one. Obtain the Fourier series for the function f of x equals to pi square by 12 minus x square by 4, valid in the interval minus pi to pi. Here f of x is defined in the interval minus pi to pi. The Fourier series of f of x having period 2 pi is given by f of x equals to a0 by 2 plus summation n equals to 1 to infinity an cos nx plus summation n equals to 1 to infinity bn sin nx. Let us take it as equation 1. Okay. Now we need to check the nature of the given function. We shall check f of x equals to pi square by 12 minus x square by 4 for even or odd nature. Okay. Yeah. By substituting x equals to minus x. F of minus x equals to pi square by 12 minus of minus x whole square upon by 4, that is equals to pi square by 12 minus x square by 4, which is nothing but our given f of x only. After substituting x equals to minus x, we are getting the same function f of x. Therefore, the given function is even. Okay. Since the given function is even, bn coefficient becomes 0. Now we need to find the coefficient, the value of the coefficient a0 and an. Now a0 is equals to 2 by pi integration 0 to pi f of x dx. That is equals to 2 by pi integration 0 to pi into bracket pi square by 12 minus x square by 4 into dx. 2 by pi into separately applying the integration for bracket terms, that is integration 0 to pi square by 12 into dx minus integration 0 to pi x square by 4 into dx. Next, first term you can see that pi square by 12 is a constant. Keeping this constant as it is, integration of here it is nothing, pi square by 12 into 1 will be there. Integration of 1 with respect to x become x, that is 2 by pi into bracket pi square by 12 into x minus integration of x square is x cube by 3, that is x square by 4 is there. 1 upon 4 keeping constant, integration of x square is x cube by 3 between the limit 0 to pi. 2 by pi into bracket by 12. Next, applying the limits here. For upper limit pi minus upper limit pi, lower limit 0, that is pi minus 0 minus, here you can see it is 4 into 3 12, 1 by 12 into bracket upper limit pi that is pi cube, lower limit 0. 2 by pi into taking 1 by 2 common, we are left with 1 by 12 taking common, pi square, pi minus 0 is pi into pi square is pi cube. Next, here 1 by 12 taken common, we are left with pi cube minus 0, that is pi cube only. Pi cube minus pi cube is 0. Therefore, we have obtained a naught is equals to 0. Next, en. En is equals to 2 by pi integration 0 to pi f of x into cos nx dx. That is equals to 2 by pi integration 0 to pi square by 12 minus x square by 4 cos nx dx. 2 by pi into bracket. Now we need to integrate these terms by the Bernoulli's rule of integration by parts. Pi square by 12 minus x square by 4, keeping the u term constant, integrating cos nx. Cos nx is sin nx by n between the limits 0 to pi. Next, derivative of this term, that is pi square by 12 is 0. Derivative of x square by 4 is minus 2x by 4. Next, integration of sin nx is minus cos nx upon, already one n is there, another one n means n square between the limits 0 to pi, plus next derivative of this term, that is minus 2 by 4. Okay, 1 by n square as it is, integration of cos nx, that is sin nx by n, and already n square is there, n into n square is n cube between the limits 0 to pi. Since we know that sin n pi is 0, sin 0 also 0, first term and third term becomes 0. We are left with only second term, that is minus 2x by 4 into minus cos nx by n square between the limits 0 to n, that is 2 by pi into bracket 2 ones are 2 2, that is minus x cos nx upon 2n square 0 to pi. Taking 1 upon 2n square outside the bracket, that is 2 by pi into 1 upon 2n square in bracket cos pi. Substitute the limits. Pi cos x cos nx is there. Pi cos n pi minus lower limit 0. Here 2 cancels. 1 upon pi n square into bracket pi cos n pi, that is pi cos n pi minus 0 is pi cos n pi. Again pi cancels here. We are left with cos n pi upon n square, and we know that cos n pi is nothing but minus 1 raised to n. n is equals to cos n pi by n square. Cos n pi is minus 1 raised to n, therefore minus 1 raised to n upon n square. Okay. Here we have a naught equals to 0, n equals to this one, and we know that since it is a even function, bn is 0. Therefore equation 1 becomes f of x equals to 0 plus summation n equals to 1 to infinity minus 1 raised to n upon n square cos nx plus 0. Nothing but f of x equals summation n equals to 0 to infinity or n equals to 1 to infinity minus 1 raised to n upon n square into cos nx. This is the required Fourier series.